Assalamu alaikum wa rahmatullahi wa barakatuh. The audio has been checked. Yes, I am being recorded. So let's do it. Now, in the fourth case, you know what? Before I start writing about the fourth case, before we start learning about the fourth case, it's better, way better if I was to tell you the pattern. Because once you know the pattern, it becomes extremely easy to memorize, know, and apply all of these cases, okay? Now, take a look at this. So, in the first case, we were converting from decimal to binary, right? In the second case, we were doing the same thing. The only thing that changed was that the mantissa was now negative, right? And we had to take 2's complement in the very end. Okay, so let's say that there are two pairs of the cases. The first pair you've got, from decimal to binary, right? Now, in the third and the fourth case, let's just talk about the first case for now. In the first case, the first one is the positive way, the second one is the negative way, right? And remember one thing, let's talk about the second pair, right? And the second pair, let me tell you one thing, both of the pairs are just opposites, exact opposites of each other. But the negative and positive rule still applies. So the third case was for the positive one. For the fourth case, this is for the negative one, right? So, I mean, I think you would have all guessed by now what is going to be different in the fourth case. You know, the mantissa has been given to us. This time it's going to be negative. And we're just going to take 2's complement and we're going to turn it into a positive one, right? So I'm going to write a random mantissa, a negative one this time, right? And we're just going to solve it, okay? What I just said right now, I think it would be better before we dive into the fourth case. I think it's better if I just write what I just said because I think I fumbled a bit, and even sometimes when you're saying something straight, even that can sometimes cause confusion. So, and the way I said it, I fumbled, I stuttered. That way, I think it would have caused just more confusions. Let me write it this way. Let's make two pairs. When I write 1, 2, 3, 4, I'm referring to the cases, right? So case 1 and case 2. This is for the positive one, right? From the positive decimal number to the binary. The second case is about the negative positive number to binary, right? Let's make this one thing appear. For the third and the fourth case, this is again for the positive binary number to the binary number, and this one for the negative binary number to the binary number, right? This is what we have ourselves. You see the pattern? You see the pattern? And another thing is, both of these are exact opposite. Both of these pairs are exact opposite of each other. So in the first two cases, you're converting from, the decimals to the binary, and in this case, you're just converting what? The binary to the decimal. So you're just going, the other way around, you know, or if I should put it this way, they're just both exact opposites or they're just the reverse working of each other. This is the pattern which I think you should remember because that just makes it easier for it to stay in your head. It's not like they're going to ask you, hey, what is the pattern that you learned in class for all of the four cases? This question is never going to appear in your exam, obviously, but it's good to know, right? Now for the fourth case, I'm just going to write some random values. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to also write it in 8 bits, right? Bismillah. Let's do it this way. Now look, another thing, how do you know that the binary number you're looking at is actually a negative number? Like, how do you know this is case 3 or 4? Because look, the moment you see in the exam you have been given a mantissa and the exponent, then you have to find the binary number for that, right? But how do you know whether it's the third case or the fourth case? How do you know that the binary number is positive or negative? Because unlike the binary numbers, you don't use signs in there, right? These are unsigned binary numbers. These are unsigned binary bit combinations, or however you want to put it forth, right? So in that case, this is how you know. The very first bit or the last bit from the last bit or the first bit from the left side, or another way of saying this is I'm sorry, is the left most significant bit. The left most significant bit is what we are talking here, right? And that is what? 1. If the first bit from the left side is 1, then you know it's negative. You know it's negative. Okay? And then you just write, let's say, 1 0 1 0 1 1 1. I'm just going to make it the exact opposite of this. Exact opposite of this, right? I don't know. I mean, I said I'm just going to use a random one. So this is random from my, brain. This is the mantissa that we have been given, right? And then the exponent, let's just not change the exponent. We're going to keep the exponent same. It's going to be 0 0 1 1, right? So obviously the very first step here is, step 1 is 0 0 1 1 1 8 8 1 1, sorry, 1 2 4 8, right? So you know both of these add up, you get yourself a 3. So 3 is your what? Exponent, right? Just like we did in the last question. Now in here, the second part was to find the decimal. Now before you find the decimal, or before you do anything with the mantissa, what is the first thing that you're going to do in here? The additional step for case 4, just like, you know, what? Case 1 and case 2 were the same, but there was an additional, step, the fourth step at the very end in case 2 to deal with the negative sign. Case 4 is also just like case 3, exactly the same methods, the same everything, but with the negative aspect, with the negative thing, with the fact that the negative exists, we are going to do what? We're going to have to change something. And that is the additional step for case 4. So before you start doing anything with the mantissa, you have to take the 2's complement in order to convert it back into, the positive one. And that is going to be 1 1 0 1 0 1 1 1. You know what? Let's just write it, let's just invert it, okay? Let's just take the 2's complement. That would be 0 0 1 0 1 0 0 0, and then you add a 1 in here. You get yourself 0 0 1 0 1 0 0 1. Okay? This is what you have. Now you know where the decimal is going to be. Obviously, it's going to be here, right before the last bit or right before the least significant bit, or the left most significant bit. The exponent is 3, so you move it, sorry, the exponent is positive 3, so you move it 3 places to the right, and you have yourself 0 1 0 point 1 0 0 1, right? And you've got yourself the answer, right? This is going to be 1 2 4, so you have a 2 here. This is going to be 0 0.5 0 0.12, oh sorry, 0 0.25 0 0.125, and no, not a new page. This is going to be 0 0.0625, right? Zero point zero six two five, right? This is how you add it. 0 0.5 0 0.0625. So that becomes 0 0.5625, right? 0 0.5625. This is your answer, right? This is your answer, literally. So in case 2, now you know what? You see one thing? This is it. This is just as easy as this, and nothing more than that. Remember one thing though. Do remember one thing. You do have to write a negative sign at the end. Don't forget this, because the only reason you converted this negative mantissa into a positive mantissa was for your own convenience, so that you can do it exactly the way you would have done it had it been a positive one, right? So you converted it, you took the 2's complement, you did whatever you had to do, right? And you changed it, right? But once you finally get your answer, you do need to remember the fact that this came from a negative mantissa, so it has to be a negative number. It has to be a negative binary number, right? Another thing in here is that let me just, you know what? Let's just do that all once again. I'm going to copy it and in here I'm going to paste it. Okay. Now look, I know this is not an entirely separate case and I hope that the lecture is not way too long. Nope, it's not. Well, it kind of is. Never mind. You know, I'm going to wrap this up now. So look, let's take a look. Let's say that this wasn't our exponent. Our exponent was a bit different. Our exponent was, let's say, 1011. Now, in this case, what is negative? You know what? I'm not going to be taking the 2's complement again. I'm just going to copy this. It was 0010. The answer was 0010, 0010, 1001, right? So we got ourselves the answer. This is the 2's complement, right? Pardon me for that. Now look, so let's say now look, in this case, our exponent is negative. So how do you convert that? This is going to be 1, 2, 4, and a negative 8 this time. A negative 8. You want to know why? Because there's the least significant bit or the leftmost significant bit is what? It's 1. So you know it, right? So what is going to be the answer for negative 8 plus 2 plus 1, right? So it's just like you're subtracting 8 from 3, right? You get yourself a 5, but negative 5, right? So this is just how you solve it. This is going to be a negative 5, right? Now you know where 0, 0, 1, 0, 1, 0, 0, 1, right? This is where it is. Or rather, I think I should write it here. Now, because it's a negative, your exponent is negative, instead of the decimal place moving right, it's going to move to the left side. Or rather, I should say it's going to move 5 places to the right. Okay? You know? And that is going to be 1, 2, 3, 4, 5, 6, right? And this is just how you do it. I'm not going to solve it because honestly you're not going to get this type of a question. Honestly, you're not going to get this type of a question where where the decimal side is way too big. You're not going to get that kind of a question where the decimal side is way too big, right? I think in order to make this easier, I can do one thing. I can do this, right? If this is your exponent, you know in that case it would be negative 8 plus 4 plus 2 plus 1, and that gives you a negative 1, right? So let's just write a few extra zeros in here. This means this is going to go one place to the left, not to the right. Why? Because it's not positive. So this is how it works. It goes here, so you're left with 0.00101001, right? So that would be 0.5, 0.25, 0.125, right? And then you just add them all up, right? I would rather not do it. Why? Because I mean, you already know. I just the only thing I wanted to put emphasis on was the fact that if your exponent is negative, then you move your decimal point in the opposite direction. Instead of the right direction, you move it into the left direction, right? But it's not going to be such kind of a question where your decimal side is going to be this big, and moreover, this question is what I made up on my own. This wasn't an actual past papers question. I just did it just so that I can tell you that the exponent can also be negative. So, Alhamdulillah, we are finally done with all of the 4 sides, right? All of the 4 sides. Now, all that we have got to do is just, do a few past paper questions. for that, and inshallah ta'ala we're going to be done with it. The first chapter is not done. We are not done with the first chapter yet. The only thing we're done with right now is, the first part of the first chapter, right? Because there are a few other things that we do have to take into consideration. For example, let's just take a look at the syllabus. Yes, user-defined data types still remain, right? I think there's more. I do need to. Yep, there's the file organization methods and then the user-defined data types. In the second one, we're going to start with the user-defined data types, inshallah ta'ala. Okay, so that was it for today's lecture. Assalamu alaikum wa rahmatullahi wa barakatuh.